Everyone, Nitesh this side. So let's start with the question. So the question is maximum depth of a binary tree. So you have given the root of a binary tree and you have to return its maximum depth. Okay, so let's see with an example. So you have given a binary tree and you have to calculate the depth of a binary tree. And depth is basically from a root node to its existing leaf node. Okay, to its deeper leaf node. So if I have to calculate the depth for this root node, I can see like it will be go to this node. This is not the leaf node. I will go to this node. This is a leaf node because it's have no children like left and right. So for this, I can say the depth is 3. Let's take one more example. Let's say I have a tree of like this 1, 2, 3, 4. Okay, so I have to calculate depth of this root. So I can go to its left also and I can go to its right also to check which is the leaf node. So I can easily see like this 3 is my leaf node, and from this I can return my depth. So basically for this case also my depth is 3 because from the left I just get only 1 as a depth, so that's why it is lesser. So we will take the maximum depth. Okay, so let's see how we can approach for this question. Okay, so let's see our first method. Let's calculate the depth by using recursion. Okay, so what we will do is basically from a node, what we do, we call its, let's call a solve function. We call its left child, not dot left. Similarly, we will call its right child, and whoever gives the maximum depth, we will just do +1 to it. Okay, so let's see with an example. So we will calculate for this node. Okay, we will call its left child and we will call its right child. Okay, so let's solve this method first, this node. So we will call its left child, which is null, and we will call its right child, which is null. Okay, so whenever we encounter any node as null, we just return 0 from here. Okay, so we will return 0. Okay, and we will return 0 from here. Okay, so we have done for this left child, we have done for this right child. So we will done with the step of this left children also. So we will return back to it. So what it will return, it will do the maximum of left, which is 0, and maximum right, which is 0, and by doing +1, because we need to consider this node also. That's why we are doing +1. Okay, so this will return 1. Okay, now let's solve the right part. Okay, so we will go to this 20. 20 will call its left and right, so it will call its left. Similarly, it will call its right. Okay, now this is basically a recursion call. Recursion call is basically I just call the part you have to do and you have to implement it by yourself. Okay, now this will call its left children. Similarly, this will call its right children, and they both return 0 because they are null. This will also return 0. So from here, I can easily return 0 and 0. So 0 is maximum, and by +1, it will return 1. Similarly, for this case, it will also return null, null, and 0, 0. And we're doing 1. Okay, this will return 1. Now, I have for this 20 children, okay, for this 20 node. From left, I am getting as 1, and from right also I'm getting as 1. So the maximum is 1 comma 1 is 1. And what we will do +1 to it. So it will become 2. Okay. So as you can see, for 3, our left is returning 1 and the right is returning 2. So maximum of 1 and 2 is 2, and we do +1. Okay, so for this case, what's the answer? We get the depth as 3. Okay, so I hope recursion approach is clear to you. There will be one more approach which I will also tell you. Okay, so let's see how we can do the same problem with level order or BFS. So as you know, for level order, what we will do, basically if you know the level order, like this is level 1, this is your level 2, this is your level 3. So the final level will give you the depth of a tree. So what we, for level order, you already know we need a queue. Okay, so let's create a queue. This is our queue. Okay, so what we will do, we will take a level variable also, which will start from 0. Okay, so what we will do, first we will insert our node into the queue. Okay, and we will increase our level by 1. So when we pop out this, what we will do, we will insert its left children and its right children. So we will insert 9 and 20, and we will increase the level also, so it will become 2. Okay, so when we remove 9, we can easily see it is not having left children and right children, so we will not increase level. So we'll go deeper, we'll remove 20 and insert its left children 15 and 17, and we'll increase our level. It will become 1 plus 1, 2 plus 1 is 3. After that, we will remove 15, and 15 is not having left and right, so it will not do anything. And similarly, 17 will not having left and right, so it will not increment the level. So the final output for this case is level, a local variable level, which give us 3. Okay, so let's see. And let's say we want to compare like which is better. Like if we have to calculate the worst case for both scenario. So for level order, let's say in the last loader, let's say this. Okay, so as you can see in the every last order, I have to take all this into a particular queue. Okay, so for level order, as already know, we are using queue. So the size might be large as compared to recursion, because in recursion, what we are not using any extra space. The extra space is just the stack call. So in that case, this, if we go with the recursion option, then it will be good. But let's say if your tree is a skew tree, basically it will be like left skew tree. Then what you are doing, you are going in one direction only, depth wise. So you are storing all this recursion call. In that case, level order is best. So both basically is good, but it depends on the problem on which you are solving. But for like majorly use case, we go with the recursion. Okay, so let's write a code for this. Okay, so what we need is a base condition and a recursive case. So let's write recursive case first. So what we are doing is calculate the left path, left equal to max depth of root dot left. Similarly, we will calculate the right part, max depth root dot right. And what we do, we do the maximum of left and right, left comma right, and we just return +1. Okay, so this look good. Let's write the base case also. So base case is pretty simple. It's root equal to. So if our root become null, we just return the 0. Okay, so let's run the code for this. Okay, so this is accepted. Let's submit it. Let's see. So this is also accepted. So thank you for watching this video. Hope you like my content.